In this lesson, we are going to solve polynomial and rational inequalities. So first here, we're going to start with polynomial inequalities, and we will solve by graphing and algebraically. So this first one, we're asked to solve x plus 3 times the quantity x minus 1 squared greater than 0 by graphing that polynomial. So here, if you look, we have the graph of that polynomial, and we are just looking, where is it greater than 0? Well, look on my graph here. It's pretty much this whole area, but we have to be careful because it's not greater than or equal to 0, it's just greater than 0. So the x-intercepts are not included. So our solution would be the interval -3 to 1 in union with 1 to infinity, because 1 cannot be included and the -3 is also not included. And that is our solution set. Now, solving a polynomial inequality algebraically, first thing you want to do is make sure we have it greater than, equal to, whatever it is, to 0. So we want everything on one side and 0 on the other side. So the first thing we're going to need to do here is subtract x from both sides and get x to the 4th minus x is greater than 0. And what we're going to do first is find the real zeros. And in order to do that, we're going to have to factor. So I'm going to factor out an x, left with x cubed minus 1. X cubed minus 1 is a difference of perfect cubes, so that factors into x minus 1 times x squared plus x plus 1 greater than 0. And if you look at all of those and solve, we get x equals 0, x equals 1, and then the x squared plus x plus 1 has no real solutions. And then what we're going to do is use the real zeros to separate into intervals. So our intervals then would be from -infinity to 0, from 0 to 1, and 1 to infinity. So we will test a number in each of those intervals to determine if it's greater than 0 at that spot or in the interval. So test a number. In each interval. So if we find, well, first of all, we're using f of x equals x to the 4th minus x. So if I find f of -1, that's equal to +2, so that's above the x-axis. If I test 1/2, f of 1/2 is equal to -7/16, so that is below the x-axis. And then f of 2 equals a +14, so that's above the x-axis. So remember, those x values are my x-intercepts, so we just have greater than 0, so those will not be included in our solution here. So from -infinity to 0, it's above the x-axis, in union with 1 to infinity. And then it asks us to graph the solution set. That just means on a number line. All right, so since our endpoints are not included, we typically use open circles, or you might see the parentheses. Just depends on kind of what book you're using. I like to use open circles, so we'd have an open circle on 0 and shaded to the left because it's from -infinity up to 0. And then from 1 to infinity, so an open circle on 1, shaded towards infinity. Again, you might see something like the parentheses like this instead. Either or, you're not going to see both on there. All right, solving rational inequalities. First, using a graph, it's the same idea here. So looking at the graph of x minus 1 over the quantity x squared minus 4, we're looking for greater than or equal to 0. So that would be here. And also this entire interval. Now, it's greater than or equal to, so our x-intercepts will be included. So my inbound for my left-hand side is actually my vertical asymptote of x equals -2. So it's going to be -2 to +1, where 1 is included. In union with, we go from the vertical asymptote of x equals 2 to positive infinity. It is above the x-axis that entire time. And last one here, solving a rational inequality algebraically. First thing we need to do is get 0 over there on the right-hand side. So this would be 3x squared plus 13x plus 9, all divided by the quantity x plus 2 squared minus 3 less than or equal to 0. I'm going to go ahead and expand my denominator here. So that would be 3x squared plus 13x plus 9, all divided by x squared plus 4x plus 4. I'm subtracting 3, and I'm going to leave some space, because in order to subtract a fraction, we have to have a common denominator. So I'm going to have to multiply that 3 by x squared plus 4x plus 4 over x squared plus 4x plus 4. Alright, so I now have 3x squared plus 13x plus 9 minus 3x squared minus 12x minus 12, all divided the common denominator of x squared plus 4x plus 4 less than or equal to 0. And we're going to simplify. So we have 13x minus 12x would just be x. 9 minus 12 would give me minus 3. All over, I'm going to go ahead and put this back in factored form. X plus 2 quantity squared less than or equal to 0. So no simplifying happening. That's the inequality that we're working with. Alright, so next we need to find the x-intercepts or the real zeros. We do that by taking the numerator and setting it equal to 0. So that happens at x is 3. And then we have our vertical asymptote, and that's x plus 2 equals 0, so x equals -2. That does have a multiplicity of 2. That would help us with our end behavior on both sides, but not too worried about that. We just need to know that the vertical asymptote is at x equals -2. We will now make our intervals. So that would be from -infinity to -2, -2 to +3, and then 3 to infinity. Test something in the interval. So if I find f of -3, that is equal to -6, so that is below the x-axis. F of 0 would be an easy one, is -3/4, so that's below the x-axis. And then f of 4 is equal to 1/36, So that whole interval is above the x-axis. All right, so using that information, we're looking for when that function is less than or equal to 0. So that happened in these two intervals. Let's see, -2 is the vertical asymptote, so it will not be included. 3 is the y-intercept. It will be included since it was less than or equal to. So our solution set is from -infinity to -2 in union with -2 to -3, where -3 is included. For a graph, we would have an open circle, -2, shaded to the left to -infinity, and then we would have an open circle on -2, and then it goes to that would go to +3. I wrote that down wrong. Okay, yeah, just wrote it wrong. Second part of our solution set is from -2 to +3. So that would just be shaded up to +3 with a closed circle. And again, in some textbooks, maybe you would see parentheses like this and a bracket like this to display the interval. And there you have solving polynomial and rational inequalities.